All right, we are on the last section, the last lesson of the first chapter, and we are going to talk about interpreting graphs of functions. So let's go ahead. Let's talk about some definitions first. The x-intercept, you might have more than one of these, but it's basically any point where if you have a graph, that graph crosses the x-axis somewhere. And a y-intercept, same thing, but it crosses the y-axis instead. So we're going to have to learn how to find those. Line symmetry is what a graph has if you can draw a line somewhere in the middle of the graph and the left half and the right half are mirror images of each other. That's called line symmetry. The positive part of a function, or a positive function, is that part of the function where the graph is above that x-axis, and then obviously negative function is where it is below the x-axis. We talk about increasing functions and decreasing functions, and when we do that, we are reading the graph from left to right. We never read it from right to left. So when I talk about increasing and decreasing, I talk about what's happening as the graph goes to the right. So if the graph goes up and to the right, that is an increasing function, and if the graph goes down and to the right, that is a decreasing function. So there's the difference between those two. A relative maximum is any part of the graph where it reaches like a high value, like a hill, and then decreases after it. And a relative minimum is where there's like a valley, it reaches a low point and then comes back up. Okay, we're going to see visual examples of all of these. End behavior is what's happening as the graph goes very, very left off of the actual graph that you can see and very, very right off of the graph. So it's just looking at what's happening as you go very, very far into x equals negative infinity and x equals positive infinity is what they like to call it. So let's look at specifically the first few of those, intercepts, positives, and negatives. So the x-intercepts on this graph are where the red curve crosses the x-axis, that horizontal axis, and there's 4 of those labeled with blue points. The y-intercept is going to be where it crosses the y-axis, which is that one pink point right there. The graph is positive anywhere that it goes above the x-axis. So I've labeled those with green parts of the curve. Those are the spots on the graph that are above the x-axis, and then the negative spots are obviously everywhere else where it's below the x-axis. And so what you should notice is that the green and the purple are always separated by a blue dot. What that means is the x-intercepts separate the graph into the positive parts and the negative parts. Okay. So now we have extrema, maximums, and minimums, and we talk about increasing and decreasing. So the maximums are the tops of the hills, which are right here because the graph goes up and then goes down. And then the minimum, there's only one of those at that pink point right there, and that's where the graph goes down and then comes back up. Increasing, remember we're reading from left to right. So anytime the graph goes up and to the right, that is where it is increasing. So I've labeled those with green curves, and then any spot where it's going down and to the right, we consider that decreasing, and I've labeled those with purple. And just like the x-intercepts separated the function from the positive parts and the negative parts, the blue dots and pink dots separate the green and purple areas. So in other words, the maximums and the minimums separate the graph into the parts where it's increasing and decreasing. And then finally, end behavior. We're just looking at what goes on at the very, very left and the very, very right. So it can level off, it can go very, very up, or it can go very, very down. So notice as we go very, very far to the left, the graph goes down, and we say that as x approaches negative infinity, y approaches negative infinity. And then as we go very, very right, the graph also goes very, very down. So as x approaches positive infinity, y again approaches negative infinity. So here's a final example. We've got x-intercepts at 3.8 and 6.9. That's where it crosses the x-axis. We have a y-intercept at 7.5. That's where it crosses the y-axis. We have a positive function for x's that are less than 3.8. We have a negative function between 3.8 and 6.9, and then we have positive x's. We have a positive function for x's that are greater than 6.9. Now, talking about maximums and minimums, I have a maximum at -1 and 8.2. I have a minimum at -5.5 and 1.5, and I have a minimum again at +5.5 and -2.5. The function decreases before I get to -5.5. It increases between -5.5 and -1. It decreases again between -1 and +5.5. and then it increases after I leave 5.5. And finally, as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches positive infinity. And that's kind of that entire graph in a nutshell. So, a lot to absorb, but if you have any questions, please let me know, and I will see you tomorrow.